Okay, I'm going to get rid of this stuff from example 4. And we're going to go to example 5. Got 4 more, so we'll get to a total of 8. And this equation looks like this. X squared over 25 plus y squared over 4 is equal to 1. So that's an ellipse, and we can tell it's an ellipse because it's got an x squared and a y squared. Okay. If you were to multiply through by 100, you would get 100. I'm sorry, you get 4x squared plus 25y squared is equal to 100. Right? If you're multiplied through by 100, you get that. So you can see you have an x squared and a y squared, but there's different numbers in front of the x squared and y squared, which makes it an ellipse. Ellipses and circles are very similar, just there's different numbers in front. Both the x squared and the y squared are positive. Looks complicated, super easy to graph. In this case, the center is 0, 0. There's just an x squared and a y squared. So we center at 0, 0. So center is 0, 0. And then what we have here is we see that there's a 25 under the x squared. What that means is that since the square root of 25 is 5, it's stretched 5 units in the x direction. So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So 5 units in the x direction. Okay. Under the y squared, there's a 4. The square root of 4 is 2. So that means it's stretched 2 units in the y direction. So up 2 and down 2. Notice what you have is you connect those. You have an ellipse. Simply the square root of what is underneath the x squared tells you how far it's stretched horizontally. And the square root of whatever sits under the y squared tells you what is stretched vertically. And so we have two things, the major axis and the minor axis. The major axis is where it's stretched more. So it's stretched more this way, and that's a total of 10 units. So the length of the major axis is 10. The length of the minor axis in this case is 4. And that's all there is to sketching an ellipse. We'll look at one that's in a little bit different form. So already do example 6 here. We have x squared plus 2x plus 2y squared minus 4y minus 1 is equal to 0. So as you look at that guy, it's like, what shape does it make? Well, it's an ellipse. And the reason why it's an ellipse is because you have a positive x squared and you have a positive y squared, but there's different coefficients in front of the x and y squared. That makes it an ellipse. So I'm going to complete the square. I have an x squared plus a 2x plus a 2y squared minus a 4y is equal to 1. We'll put the 1 on the other side. Before I complete the square, I'm going to factor out the 2. X squared plus 2x plus 2 times y squared minus 2y. Notice that in order to complete the square, we will add 1. So I'm going to add 1 over there. Okay. In order to complete the square here, I add 1. But because it's times 2, we actually added 2. We didn't just add 1, so I add 2 over here. And so we have x plus 1 quantity squared plus 2 times y minus 1 quantity squared is equal to, that's a 4 over there. Now the thing about ellipses and hyperbolas, if you notice from our first example, is they always want to be equal to 1. So in order to put it in its appropriate form, we have to have it equal to 1, so I divide through by 4. So x plus 1 quantity squared over 4 plus y minus 1 quantity squared over 2 is equal to 1. Now, let's see if we can figure out some important characteristics here. Number one, the center. The center is going to be back one and down one. So back one and, back one and up one. Back one and up one. So negative 1, 1. So as I go to my graph, I'm going to go back one, and I'm going to go up one, and that's my center. From that spot, since there's a 4 underneath the x value, I go 2 units in the x direction. So 1, 2. So this is the endpoint there, and then 1, 2. This is the endpoint over there. Okay? Since I have a 2 under the y value, I go the square root of 2, which is like 1.4 in the y direction. So go 1.4. Down 1.4, and then connect all those together. So the length of the major axis 2 in each direction, so that'll be 4, and the minor axis, the square root of 2 in each direction, so 2 roots of 2. Okay? So a little bit of funkier completing the square work, but you've seen completing the square before, and hopefully you remember it. If you need to reach out for help, please ask me. And yeah, let's go to our last set here. Okay. So we'll go to 7 and 8 as we talk about hyperbolas. Do the easy one first and the more difficult one second. We have example number 7. We have x squared over 9 minus y squared over 25 is equal to 1. So there's no pluses or minuses up there like x minus 1 or y plus 2. So we know that the center is 0, 0. And here's how we make a hyperbola. It's not difficult, it's just different. I plot my center. I go 3 units in the x direction. Just like with an ellipse. I go 5 units in the y direction. Instead of making that oval, you make a box. The hyperbola is these kind of shapes. They either go side to side or they go up and down. If the x is positive, it goes side to side. If the y was positive, then it goes up and down. So since the x is positive, it's going to go side to side. So that means that the vertices sit right here. So one of the characteristics that you're going to find for your hyperbolas is your vertices. And your vertices in this case are going to be 3, 0 and negative 3, 0. In order to sketch the rest of this, all you have to do is draw your diagonals. These are called your asymptotes. They go right through the corners of the boxes. Once you have the box constructed, it's easy to draw the shape. You start at your vertices, and you simply just kind of travel towards those asymptotes. You don't ever cross over the asymptotes, you just travel towards them. And then this gives you the shape of the hyperbola. That's it. So let's try one more of a hyperbola. Example 8. And that is going to be x squared minus y squared plus 16 is equal to 0. Okay? Now, I can tell that that's a hyperbola because x squared and y squared, and one of them is negative. So if you see one of them negative, you know it's a hyperbola. Some of you may say that it's going to open up horizontally. Just wait till you put it in the appropriate form before you say that. There's nothing to complete the square with here for the x squared and the y squared. I'm just going to go x squared minus y squared is equal to negative 16. But I do know that the hyperbolas like to be equal to 1. So as I divide through by negative 16, you can see that both the x squared and the y squared are going to have a 16 underneath it, but the y is the one that changes to positive this time. So it's y squared over 16 minus x squared over 16 is equal to 1. So the center is still 0, 0, as you can see here. There's no plus or minus up there. And as I draw this out, from 0, 0, I go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So because there's a 16 under the y squared, I go 4 units in the y direction. Because there's a 16 under the x squared, I go 4 units in the x direction. And instead of drawing that ellipse or that circle shape, what do I draw instead? A box. Our vertices are going to sit either on the sides of the box or the top and bottom of the box. How do we determine that? We look at what's positive. Since y is positive, the vertices sit on the top and the bottom. So right there and right there. So that would be 0, 4 and 0, negative 4. And then as you go ahead and draw your asymptotes, they just go through the corners of the box, as you can see. That kind of shape is taken. So there you have it. That's a nice introduction to conic sections. Tough for a teacher to say, let's do conic sections in this situation and really do it justice. There's such depth to them. That's just a really quick overview, enough to be able to say someday you're familiar with it. When would you see conic sections? They do come up a little bit in calculus. Definitely come up a lot more in calculus 2. Not a lot are you going to see them, but it's helpful to know that they're there. The truth is that although we've been learning still, there are a number of things that we've left out mathematically that we would like to know for future years. You've gotten the essentials though. And for those of you who have me next year for calculus, don't worry. We'll find a way to build that in. So thanks for being here for week 7. Week 8 will be nice and short, I promise. Reach out to me if you got any questions. Have a great day.